Welcome back to Maths with Mrs. J. We're at the interesting point in senior high school maths where things are all starting to tie together. A lot of our knowledge about our trig functions, our inverse functions, our differentiation, all of these sorts of things are coming together. This is a great thing, I think. However, it can pose a problem for some people who haven't got their basic skills correct. If you need to go back and revise information about your basic trig functions before we launch into inverse trig functions, by all means do that. That would be a very sensible thing to do. Also, doing some research about inverse functions in general and their derivatives would be a good idea before you progress into these next series of videos. Just a word about our inverse trig functions. Obviously, we know that for a relation to be a function, the vertical line test has to work. So just thinking about our normal y equals sine of x curve, just having a little look over here. If I were to have y equals sine of x, it looks like that. Vertical line test works everywhere. We could keep going infinitely in both directions and that will be a function. However, if I'm wanting to get an inverse function to that, I can get an inverse relation quite easily. However, it will not be a function because the horizontal line test does not work and therefore the vertical line test won't work on your inverse relation. In order to ensure that we get an inverse function, what we need to do is limit our domain. The way we do that is by taking from negative pi on 2 up to pi on 2 of our y equals sine of x. For this section, we're all good as far as both vertical line test and horizontal line test are concerned. Now, what I've done is I've drawn y equals sine of x between x's negative pi on 2 and x's pi on 2 in green. And on the same set of axes, I have drawn the inverse function. We should remember that our inverse function is going to be reflected about the line y equals x. I have drawn that in orange and it looks the same shape, but it's been reflected. This is a function because we have restricted our domain of our sine of x appropriately. In order to be using our inverse sine, inverse cos, etc. functions, we need to be talking about a reduced domain of our original functions. The other thing to point out, as you probably should already know, is that when we have inverse functions, the domain of your function will become the range of your inverse function and vice versa. So notice here how our y equals sine of x, the domain is between negative pi on 2 and pi on 2. And that is actually your range of your inverse sine function. The range of our y equals sine of x is obviously between negative 1 and 1. We know that from our unit circle and from our knowledge about our y equals sine of x curve. And that will become the domain of our inverse sine function. So what we've got here is between x is negative 1 and x is positive 1. The range will be between negative pi on 2 and pi on 2. So just bear those in mind. That's important. If we're wanting to talk about functions, we need to talk about just a section of that original function. Just another word, some people use, instead of inverse sine written like that, they might write r sine or even arc sine. They are all equivalent. Whether you write it as sine with the negative 1, so inverse sine, that does not mean 1 over sine of x, by the way. That means the inverse sine. Similar thing over here with our cos. We can't take our normal cos function, it keeps going on like that infinitely in both directions. The vertical line test works, that is a function everywhere. However, the horizontal line test fails. And so for our inverse function to actually be a function, we have to limit our domain. And what we do there is we limit our domain just to between 0 and pi. This section here, we're perfectly safe both with vertical and horizontal line tests. So we know that our inverse function, which is going to look like this, will be in fact a function. Okay? Just bear in mind, for something to be a function, the vertical line test has to work. Now, for the vertical line test to work on an inverse function, that means the horizontal line test has to work on your original function. I hope that hasn't got too confusing for you. All right, similarly, as we did over here, what will happen is your domain and range will swap. So the reduced domain that we use for cos, when we're going to be then talking about inverse cos, that will become our range. And our range for our cos will become our domain for our inverse cos. Similarly to your sine, you can write it as r cos of x or even arc cos of x. It doesn't really matter. Different textbooks and different people prefer different things. It's not an issue either way, all right? As long as you realise that that is inverse sine, it's the inverse function. And also just bear in mind that is not cos of x raised to the -1. That's why we have a special name for cos of x to the -1, and that's sec of x. 1 over cos of x is sec of x. 1 over sine of x is cosec of x. All right, that just, those names have solved, well, in theory, solved that potential confusion there. All right, let's continue on. And we're going to go to our next page and have a look at tan and inverse tan. Now we know that our y equals tan of x function is obviously repeated every pi, and we have our vertical asymptotes at -pi/2, pi/2, 3pi/2, 5pi/2, etc. Everywhere where on your unit circle you're touching the vertical axis. Because, remember, tan is sine divided by cos. Cos is the x value, and the x value is 0 on that y-axis of your unit circle. So, obviously, in order to have a function as our inverse, we only take one section of this tan of x graph, and the section we take is between -pi/2 and pi/2. Again, when we get our reflection in our line y equals x, this is what we get for y equals inverse tan. Looks exactly the same, but it's a reflection in the line y equals x. Similar to over the page, our domain and range will swap. So our limited domain for our tan of x, if we're going to be taking the inverse of it, is between -pi/2 and pi/2. That ensures that our inverse function will be a function and not just a relation. The range, of course, is the set of real numbers. It goes infinitely in both directions. When we do the inverse, they swap over. So your domain will be the set of real numbers, and your range will be between -pi/2 and pi/2. Notice how over the page I included the pi/2. I had the square brackets. That's because they could be included. Here, you can't actually have those values because they are on asymptotes. So that's why I've got the curved bracket to say right up until that point, but not including. And again, just to point out that people can use the term artan or arctan. Okay, so that's just a quick introduction. We haven't done any examples yet or anything like that. Just a quick introduction to our inverse trigonometric functions. We're now going to, in our next few videos, start talking about some important properties of them and how to differentiate them and how to integrate them. So stay with us. If you like my videos, please subscribe.